5.3 part 2, still solving polynomial functions. So again, I want to review that solving means to find your zeros, your solutions, your x-intercepts, your roots, so all of those things. So now we're going to take on a little bit of something a little different, sum or difference of cubes, and we're going to learn something called SOAP. SOAP means this, and write this on your paper, please. Same, opposite, always, positive. Okay, and I'm going to show you how this is going to help you understand this very, very well. So I do have these charts on here, and you're going to look at and go, how are we supposed to memorize that? That seems so difficult, but if I show you the SOAP method, you will easily memorize this, I think. So what I want to focus on is I'm going to focus on this problem first, just to kind of show you how SOAP works, because we already have the answer here, but I'm going to show you how it works. So we're going to take our sum of two perfect cubes. 8 is a perfect cube, x cubed is a perfect cube, and 1 is a perfect cube. So these are, when I say difference, sum or difference of cubes, we're talking perfect cubes. So here's how it works. In your first parentheses, okay, you take the cube of your first term. So the cube of 8 is 2. The cube root of 8 is 2. The cube root of x cubed is x. And the cube root of 1 is 1. Now this is where the same, positive, always, same, opposite, always, positive comes in. So the sign in your first parentheses is the same as your original equation. The sign over here, the first sign, opposite. The last sign, always positive. So it goes same, opposite, always positive, because you're going to break into a trinomial. Okay? So same, opposite, always positive. To fill in your trinomial, you're going to square your a term, square this first part of the parentheses. So 2 squared is 4, and x squared is x squared. Okay? You're going to square the second term in your binomial. 1 times 1 is 1. And then you're going to multiply these two together. So 2x times 1 is just 2x. So again, look at what we get. We get 2x plus 1, 4x squared minus 2x plus 1. So we know we got the right answer. So let's kind of practice this. Let's practice the SOAP method on this first example. So we have x cubed equals 1. It says rewrite the equation equal to 0. So we have x cubed minus 1 equals 0. Very, very similar to the one I did not do up top. We just don't have an 8 in front of it. So we're going to use the difference of cubes to use SOAP. So you're going to break it into one binomial parentheses and a trinomial parentheses. First thing we're going to do, same, opposite, always positive. Same, opposite, always positive. So now I'm going to take the cube roots. So x cubed, the cube root of that is x. The cube root of 1 is 1. I'm going to square my first term, so x squared. Square my second term, negative 1 times negative 1 is positive 1. Doesn't matter, it's always positive. Okay, and then I'm going to do 1 times x, which is just x. So I have now completed the factoring part of my perfect cube. So I'm going to go ahead and scroll down so I can finish this out. And I'm going to rewrite this all up here. So I'm just going to rewrite this part, x minus 1, and then I have x squared plus x plus 1 equals 0. I'm going to leave SOAP up there for now, but I'm going to go ahead and work this out. So I'm going to go ahead and use my zero product property. Okay, and when you guys are doing sum or differences of cubes, you're going to come out with a quadratic trinomial in this parentheses that is never going to be able to be factored. You're going to always have to use the quadratic formula. Always have to use the quadratic formula. So I have a solution right here. There's my first solution, x equals 1. I'm going to use the quadratic formula for my next solution. So just a reminder, a is 1, b is also 1, and c is also 1. They're all 1. So the opposite of b, plus or minus, b squared, well, 1 times 1 is 1, minus 4 times a times c, all over 2 times a, which is 2. Okay, so opposite of b, simplify my radical. 1 minus 4 is negative 3, all over 2. Simplify the radical again just to pull out my negative, so I need to make sure I have an I. I should have an I in this problem. So the negative comes out of the radical and becomes an I in front of it. And there are my other two solutions. So my solutions in this case are x equals 1, and then negative 1 plus or minus I square root of 3 all over 2. So positive 1, and then my negative 1 plus I square root of 3 over 2, and my negative 1 minus I square root of 3 over 2. There are my three solutions. 1 real, 2 imaginary. Next example is just the opposite. Instead of a minus, we're going to have a plus. We have already rewritten the equation equal to 0. That part is done, so we're good there. So now I'm going to use my SOAP method. Okay, same, opposite, always positive. Same, opposite, always positive. Now I'm going to take the cube root of x cubed, the cube root of 27. I'm going to square my first term, so x squared. I'm going to square my last term. 3 times 3 is 9. I'm going to multiply my two terms together, 3x. I'm going to break this apart. And I'm going to get x equals negative 3, solution 1. Okay? And I'm going to break this into equals 0. And I'm going to use my quadratic formula. So a equals 1, b equals negative 3, c equals 9. So the opposite of b, positive 3, plus or minus, b squared, which is negative 3 times negative 3 is 9, minus 4 times a times c, all over 2 times a, which is 2. Okay, so 3 plus or minus the square root. So 9 minus 4 times 9 is 36. So 9 minus 36 all over 2. 9 minus 36 is negative 27. Okay, I'm going to break my negative 27. I'm going to do that just kind of up here so you can see it. I'm going to break that into negative 1 times 9 times 3. I can take the square root of negative 1. It becomes I. I can take the square root of 9. It becomes 3. I cannot take the square root of 3, so it stays. So the negative 1 becomes I out front. The 9 becomes a 3. I take the square roots of these things, and they actually come out of the radical once I take the square root. But my 3, I cannot take the square root of, so I leave it under the radical, all over 2. I cannot simplify because 3 and 3 and 2, they do not all have a common factor that I can divide by. So, one solution of negative 3, and then 2 solutions down here that are imaginary. There are my other 2 solutions. So I've got my 3 solutions, 1 real, 2 imaginary. Example 7, last example, is called factoring by grouping. Sometimes we're not going to have something that's easily factorable in the sense of being able to just factor out a common factor or difference of squares or difference in sums of cubes. So we're going to have to look at some different ways to factor. So there is something called factoring by grouping. So group together pairs of terms with common factors. So I notice that my first 2 terms right here, they both have at least an x squared in them that I can factor out. And I notice my second 2 terms, notice I do not put the plus inside because right now I'm just adding these 2 binomials. But the 5x and 45 have a common factor of 5. So I'm going to factor out just out of this group right here. I'm going to take my x squared and I'm going to put it out front of my parentheses, leaving me with x plus 9 inside the parentheses. So if I were to multiply back through, x squared times x is x cubed, and x squared times 9 is 9x squared. I go back to my original 2 terms I have up there. I'm going to write my plus because that plus is still there. I'm going to factor a 5 out of this parentheses here, leaving me with x plus 9. So now I have these two terms that have factors. Like I have x squared times x plus 9, the quantity, and then I have this other one that's 5 times the quantity x plus 9. So I have these two products going on. Well, these two products have a common factor of x plus 9. So I can actually, just like I factored out a 5 up here, these each had a common factor of 5, these each have a common factor of x plus 9 that I can factor. Well, if I take this factor out, I'm still left with x squared. If I take this factor away, I'm left with a positive 5. So now I have factored. So I could set this to 0, and I could break this apart to x plus 9 equals 0, and x squared plus 5 equals 0 if I had to continue on, and then I could solve. I could get my 3 solutions. But I want you to notice when I factor out that x plus 9, what I'm left with becomes my second parentheses. So pay very, very close attention and do not leave this plus sign out, because we are still adding these two things together. Down here, once I factor something out, then I have to put that parentheses to multiply back through. And if you were to FOIL these two parentheses, you'd go right back to this up here.